Hello, Calculus. We are going to be doing an anti-chain rule today. I have a warm-up for you where we have done questions like this here where our inside function's linear. And let's recall our steps for this. Remember that our steps are to first anti-derive the outside function. And we're going to hold the inside, right? And then step 2 is divide by the derivative of the inside. All right, so let's go ahead and pause, see if you can do this warm-up, and do clean it up for me. So let's bring all our coefficients to the front when applicable. So let's pause and try these for me. Hit play when you're ready to continue. All right, so for this first one, our outside function is x squared. So an antiderivative for that is 1/3 x cubed, right? And we're going to hold the inside. So that's step 1. Then we're going to divide by the derivative of the inside. And the derivative of the inside is 3, so I'm multiplying by 1/3. And I already have this 1/3 out in front, so how about we make that a 1/9? And then, of course, any constant c. All right, let's take a look at this next one. Hopefully you rewrote as the quantity 4x minus 8 to the 1/2 power. So x to the 1/2 power is your outside function. So when we anti-derive x to the 1/2, we will have 2/3 x to the 3/2, right? But for step 1, we will hold the inside. All right, now step 2, we want to divide by the derivative of the inside. Well, the derivative of the inside is 4. So when I divide by 4 or multiply by 1/4, my new fraction in the front there becomes 2/12. So why don't we change that to 1/6? And of course, you can have any constant plus c there as well. All right, for this last one, hopefully you can tell that this is sort of the parent function here is the derivative of arctan, okay? So when we anti-derive the outside, it'll be arctan, and we're going to hold the inside 3x. Then dividing by the derivative of 3x is the same as multiplying by 1/3. And of course, you can have any constant there as well. All right, so we're going to extend this idea because we've only dealt with this when our inside function is linear, okay? So what if our inside function is not linear? So in this case, if we try our 2 steps, if we anti-derive the outer, we would get sine, and we're going to hold the inside, right? The inside function is x cubed. Well, when we try step 2 and we divide by the derivative of the inside, we get something like this, correct? And remember over here, we could always check our answer by taking the derivative. For example, if I take the derivative here, when I fly that 3 to the 1/9, I get 1/3 times the quantity 3x plus 7. Now I'm dropping my power to the 2 times 3, right? And so this 1/3 and the 3 multiply to be 1 and go away, and yes, I'm back to where we started, right? But if we try that here, we have a problem, correct? Because if I try to derive my answer, there is no way that I will come back to where I started, because what rule would we need if we wanted to derive this thing? We would need quotient rule, right? We would end up getting quite a mess. It would certainly not be cosine of x cubed, okay? So if we want to anti-derive these composition functions, they have to be in a very, very special format, right? So let's look at a few. Why don't we go ahead and pause and see which one of these doesn't belong? In other words, which one can you not find an antiderivative for? All right, well, if we try to antiderive here, for cosine of x, we know that that antiderivative is sine of x, right? Now here, in the second one, we have an issue, right? Now, was anybody able to find a antiderivative for 2x cosine of x squared? Yeah, we can look at sine of x squared, right? Because if I want to derive, I can always check by deriving my answer, right? So the derivative of this function would require chain rule. So I would derive the outside, hold the inside, then times the derivative of the inside, which is exactly what we started with, right? So this one, sadly, is the one that does not belong. All right, let's try one more. Which one doesn't belong and why? Let's go ahead and pause. All right, well, let's start here. We know this antiderivative, right? The next one is really similar. Look, the inside's linear, so I can go ln of x minus 3 divided by the derivative of the inside, which is just 1, so that'll work. Same thing here. Inside is linear, so I've got ln of 2x minus 3, and then I will divide by the derivative of the inside. These next two are different, right? I'm seeing some issues with this fourth integral. Can you spot an antiderivative for that last one? Hopefully you can see that we will have ln of x cubed minus 3. Because if you were to try to derive that to check, we would need chain rule. So 1 over x cubed minus 3 times the derivative of x cubed minus 3, which is 3x squared, and that is indeed what we started with, okay? So the fourth one here is the one that doesn't belong, and here's where we kind of start to see, maybe for the first time, that going backwards, anti-deriving, is not as smooth as going forwards, as deriving, okay? In fact, there are functions that we cannot anti-derive. So today we're going to be looking at functions in this very special format where we can go backwards with chain rule, okay? So I'm calling this anti-chain rule. All right, so let's remind ourselves of chain rule. If I want to take the derivative of a composition of functions, I'm going to call it capital F of g of x. Then remember we derive the outer, and let's say that capital F is an antiderivative for little f. So when I derive capital F, I get little f of x, we hold the inside function, and then we multiply by the derivative of the inside function. Okay, so using the definition of the indefinite integral, in other words, an antiderivative, if I want, I can go the other way around, right? So if I have this function in this nice format of f of g of x times g prime of x, then the indefinite integral here, the antiderivative, will be capital F of g of x, right? And then plus whatever constant. All right, so let's take a look at this format once more. Go ahead and write this format down. If you're a color coder, go ahead and color code with me. So we're going to be anti-deriving composition functions, but these composition functions, remember, have to take a very special form, right? They have to have that g prime of x in there so that we're able to reverse chain rule. Okay, so our steps are going to be really similar to what we were doing earlier. Step 1 will be to anti-derive. Go ahead and write this. The outside function. And during this step, just like before, we are going to hold the inside function and the inside function's derivative. So in other words, you're holding everything other than the outside function, okay? Now, step 2, you are going to divide by the derivative of the inside function. Now, little caveat here. G prime, the derivative of the inside function, must cancel at this point. With the exception of a coefficient, and we'll talk more about that in the next lesson. All right, so pause if you need to write some more of that down, but those are our 2 steps. Very similar to what we were just doing. Now we've kind of got this caveat of we can't be left with all these extra variables, okay? G prime has to cancel during that step 2. All right, let's try a couple examples. Let's pause here and write this example 1 down. All right, so we want to find all antiderivatives of the quantity x squared plus 1 squared times 2x. And maybe you can kind of see a pattern here. Maybe you can spot it. But let's go ahead and follow our 2 steps. So first I need you to identify the outside function. Well, our outside function in this case is going to be x squared, okay? Your inner function is x squared plus 1. Okay, so let's go ahead. Step 1 is anti-derive the outer, holding everything else. So an antiderivative for x squared is 1/3 x cubed, right? And then we're going to hold the inside as well as the inside's derivative. There's step 1. Anti-derive the outer, hold everything else. Okay, step 2 is divide by the derivative of the inside. Again, the inside is x squared plus 1, whose derivative is 2x. Now, remember that your g prime has to cancel with the exception of a coefficient. But today, all of g prime is going to cancel really nicely. Okay, so yes, those do indeed cancel. So final answer is 1/3 times the quantity x squared plus 1, and that whole quantity to the 3rd power. And don't forget your plus c. All right, the direction said to check our work. So let's go ahead and check our work. Our answer would require chain rule, right? So the derivative of the outside, when I fly that 3 to the 1/3, will cancel. I'm going to hold the inside. Don't forget to drop your power when you're deriving, times the derivative of the inside. And the derivative of a constant is 0. Well, that is indeed what we started with, and so we've got it. All right, let's pause and go ahead and write this one down. Okay, in this case, you need to identify your outer function first. Your outer function is x to the 1/5. Okay, your inside function is 4x cubed plus x. So step 1, we're going to anti-derive the outer, which will be 1/6 x to the 6th, but we're holding everything else, the inside function, as well as the inside function's derivative. Step 2, divide by the derivative of the inside function. Well, the derivative of the inside function is 12x squared plus 1, right? And so we need to make sure that we can cancel that factor of 12x squared plus 1, which we sure can. So final answer, 1/6 times the quantity 4x cubed plus x, all to the 6th power, plus c. Again, let's check our answer by deriving what we got. When we fly that 6 to the 1/6, those go away. Hold the inside of 4x cubed plus x, drop our power, there's step 1 of chain rule, right? Times derivative of the inside, which is exactly what we started with. All right, let's pause. Go ahead and write this example down. Okay, now here this might look a little bit trickier because 1, it's trig, everybody's favorite, right? The other thing is I see a power of 3 and a power of 2. So how are we going to know which one's our outside function? Well, look at your inside functions. You've got tangent and you've got secant, right? The derivative of tangent is secant squared. Okay, so remember that for that step 2, your g prime has to cancel. So g prime must be secant squared, meaning my inside is going to be tangent of x. I am going to go ahead and write that cube. Let's go ahead and rewrite it all on the outside. Okay, so my outer function is x cubed. My inner function is tangent of x. Step 1 is to anti-derive the outside. Hold everything else. Step 2, divide by the derivative of the inside. The inside function's tangent of x, whose derivative is secant squared x. Again, if we did it right, those have to cancel. Otherwise, I'm left with kind of a mess whose derivative is certainly not going to take me back to where I started. Okay, so final answer, 1/4 tangent of x to the 4th plus c. And again, you can check by deriving your answer. All right, let's pause. Go ahead and write this example down. All right, we have our outside function is what in this case? X to the 5th power, right? So and our inside function is ln of x. So when I anti-derive the outside, I get 1/6 x to the 6th. I'm going to hold everything else, the inside function, as well as the inside function's derivative. Okay, there's step 1. Now I'm going to divide by the derivative of ln of x, which is 1/x. Well, dividing by 1/x is the same as multiplying by its reciprocal, right? So let's do that. Let's change that to times, and the reciprocal of 1/x is x/1, or just x. Notice those cancel now. And so final answer, 1/6 ln of x to the 6th power plus c. All right, here's our last example. Go ahead and pause and copy. All right, so in this case, my outer function is actually e to the x. My inside function is x squared. All right, so step 1, anti-derive the outer function. Well, the antiderivative of e to the x is just e to the x, right? We're going to hold the inside function as well as the inside function's derivative. Then we're going to divide by the derivative of x squared, which is 2x. Those cancel nicely for us. Final answer, e to the x squared plus c. And why don't we go ahead and derive our answer to check? This would require chain rule, so I would derive the outer, which is itself, hold the inner, times derivative of the inner. And derivative of a constant is 0, so that works. All right, you all, that is our intro. I am going to give you the answers to the problem set here, but these are also on Canvas. All right, I will see you all next time.